Finding the area of a square is simple. Just multiply the side by itself. But how do you find the area of a circle? Even though the circle looks very similar to the square, calculating its area is completely different because it involves a special number, a number called pi. 3.1415, you know the drill. You may think that we know this number very well, but what if I told you we still don't fully understand pi? Pi is perhaps one of the most iconic numbers out there. We celebrate Pi Day, we crack punny pi jokes, and we even calculate pi to the trillionth digit and then try to memorize it. With all this in mind, pi is arguably one of the most overlooked numbers in our age. Even though we know over 100 trillion digits of pi today, there are still many things about pi that we don't know. But first, how did it all begin? Pi is a number that has been worked on for thousands of years, literally. Around 4,000 years ago, the ancient Babylonians studied the relationship between the circumference of a circle and its diameter. They approximated the circumference as about 3 times the diameter, giving pi a value of 3. And 3 is decently close to our pi today. Not bad at all for a calculator-less society. About 500 years later, the ancient Egyptians estimated pi using squares and circles. They assumed that the area of a circle was equivalent to the area of a square whose sides were 8/9 of the diameter of the circle. The diameter is twice the radius. And using the formula for circle areas that we know today, this calculation produces a value close to 3.16 for pi. It's close, but only precise down to 2 digits. But then Archimedes came along. Archimedes made one of the most famous breakthroughs in estimating pi. By trapping a circle between 2 polygons, he was able to use the method of exhaustion to narrow down the possibilities for the circumference of the circle, and therefore create bounds for pi. To visualize Archimedes' idea, start with 2 hexagons, one inside the circle and one outside. The inner hexagon touches the circle at only 6 points, so its perimeter is smaller than the circle's circumference, while the outer hexagon slightly encloses the circle, making its perimeter larger than the circumference. If you double the number of sides on both polygons to 12, and then 24, 48, and so on, their shapes began to hug the circle more closely. By using polygons with 96 sides, Archimedes was able to use this method to accurately narrow pi down to the second decimal place. And a few hundred years later, Chinese mathematician Zhu Chongzhi carried on the torch even further. By crafting a polygon with 24,576 sides, he accurately deduced pi down to a whole 7 digits. This estimation was extremely accurate. So accurate, in fact, that it remained the most accurate estimation of pi for the next 800 years. Now, obviously, not all estimations were accurate. The Romans used 3 1/8 for pi, even though they knew 3 1/7 was a better estimation. They did this because it was more convenient for calculations. Other estimations for pi included the square root of 10 and even the square root of 8. But eventually, pi had a breakthrough. Starting in the 1500s, math underwent a revolution. In 1593, Adrian Romanus accurately calculated the first 15 digits of pi. Using Archimedes' polygon technique and some trigonometry, Romanus effectively worked with a polygon with over 1 billion sides. Mathematicians after him were able to go even further, using the same method to calculate pi as far as 39 digits. In the 17th century, mathematicians were beginning to use infinite series to calculate pi. Not long after, in the 1700s, the Greek letter pi was used to denote the number pi, and was popularized by Euler in the 1730s. Fast forward to today, and now we are able to calculate trillions of digits of pi thanks to supercomputers. But even with all this knowledge, pi remains one of the most overlooked numbers in math. Pi is a transcendental number, meaning that although it is real, it cannot be the solution of any algebraic equation with integer coefficients. Even though there are approximations like 22/7, you can't perfectly notate it as a square root or a ratio or something like that. Pi is also irrational, meaning its digits go on infinitely without repeating. No matter how many digits of pi you write out, there's always more. And yet pi is not infinite, it's finite and has a limit. And there are so many things that we think we know about pi that may not be true. For example, a popular theory is that any sequence of numbers have to appear in pi at some point because it is irrational and goes on infinitely. But we aren't sure. We don't know if pi is a normal number, meaning we don't know if every digit from 0 to 9 appears the same amount of times in pi. Another interesting thing about pi is pi doesn't just appear in circles. It shows up in some of the most unexpected places in mathematics. There's a famous experiment called Buffon's needle problem. Imagine repeatedly dropping a needle randomly onto a floor with evenly spaced parallel lines. Each line is spaced n units apart, and the needle has a length of half of n. Amazingly, the probability of the needle landing over one of the lines is 1 over pi. Despite all the things we don't know about pi, there is still a lot that we do know. I mean, over 100 trillion digits? That's insane. The accuracy of pi that we have today is completely mind-boggling. American astronomer and mathematician Simon Newcomb once said, 10 decimal places of pi are sufficient to give the circumference of the circle to the fraction of an inch, and 30 decimals would give the circumference of the whole visible universe to a quantity imperceptible with the most powerful telescope. Even though we know trillions of digits of pi, 10 to 15 digits is enough, even for NASA. But when considering the irrational nature of pi, a trillion isn't all that much at all. Starting from humble beginnings of 3,000 of years ago, our knowledge of pi has come a long way. A number that is used in architecture, space exploration, sound engineering, and so much more, pi is everywhere in our daily lives. Yet, despite all the digits we've calculated, we still don't fully understand pi, and it continues to fascinate us, even today. If you found pi interesting, be sure to subscribe because the next video will touch on another very important number, an exceptionally essential exponential.